Betelgeuse, the enormous red supergiant closest to Earth, has demonstrated an extraordinary decline in brightness in recent years, sparking a wide range of reactions worldwide. Some theories suggest this fading might signal the approach of a supernova, a catastrophic explosion, that raises concern among scientists and the general public alike. Betelgeuse, a major star in the Orion constellation, has regained some of its former brilliance. Despite dimming, it appears to be entering a phase of reduced activity. Currently, experts are contemplating the future of Betelgeuse and whether its eventual detonation could have any impact on Earth. Orion is one of history's most famous constellations. In the sky, it is well known for its two primary stars, Rigel and Betelgeuse. The latter, also referred to as Alpha Orionis, is the largest and most luminous star in Orion. Observations made by NASA's Hubble Space Telescope and various other observatories revealed that Betelgeuse underwent an extraordinary 2019 mass ejection, an occurrence never recorded in any other star. Despite the fact that coronal mass ejections, CMEs, are relatively common and typically caused by our Sun, this particular outburst from Betelgeuse is unique and has generated significant intrigue among astronomers. This massive burst of mass expelled by the star was 400 billion times greater than the typical CME observed in stars like ours, briefly obscuring some of its light and leading to its unusual dimming. Estimates regarding the distance of Betelgeuse from Earth vary, with some placing it as far as 724 light-years away. Measuring the distance to red supergiants such as Betelgeuse is challenging due to their unusual characteristics and vast distance. Betelgeuse is one of the most luminous stars visible from Earth, shining with about 100,000 times the brightness of our Sun. However, such intense luminosity comes at a cost. Betelgeuse is expending its energy rapidly, burning through its fuel and speeding up its inevitable demise. The star will eventually exhaust its fuel supply, collapsing under its own gravity and potentially triggering a supernova, a violent explosion that might eventually leave behind a neutron star or a black hole, assuming current theories hold water. Could Betelgeuse pose a danger to Earth if it were to explode as a supernova? The outburst could have disastrous consequences. Supernovae are capable of emitting light so bright that it can compete with an entire galaxy. Even if Betelgeuse is relatively distant, such an explosion would be hard to ignore. Since the last supernova observed in our galaxy was in 1604, and the most recent one in 1987 occurred in the Large Magellanic Cloud, located 169,000 light-years away, the destructive potential of a nearby supernova remains an intriguing yet concerning possibility. If such an event were to occur in our galaxy, it could have profound implications for Earth. Although spectacular, supernovae are much less powerful than gamma-ray bursts, which are on an entirely different scale. While supernovae have the potential to eliminate biospheres and cover planets in deadly radiation, it is their ability to strip away a planet's ozone layer that is particularly troubling. A weakened or destroyed ozone layer exposes the planet to harmful ultraviolet radiation, which could result in an extinction event. The initial radiation burst from a supernova is dangerous, but the more insidious threat is represented by cosmic rays that arrive hundreds of thousands of years later. These are capable of further damaging the planet's surface and potentially preventing life from recovering. Historical records show evidence of past supernovae. For example, traces of iron-60, an isotope of radioactivity that formed during supernova explosions, have been detected in Earth's oceans and lunar regolith, suggesting that Earth may have been affected by supernovae within the past few million years. Despite this, astronomers have ruled out a supernova occurring soon. However, they've discovered a second potential risk. Certain types of supernovae emit radiation that can travel vast distances and inflict damage on planets like Earth. When a star nearing the end of its life is surrounded by a substantial amount of material, a specific type of supernova may occur. The shock wave from the initial explosion strikes the surrounding disk, triggering the emission of vast amounts of X-ray radiation. This high-energy radiation has the potential to deplete a planet's ozone layer by as much as 50%, which could induce an extinction event within a range of 150 light-years. Fortunately, no such X-ray supernovae are currently known to be sufficiently close to Earth to directly threaten it. These findings have inspired astronomers to reconsider the boundaries of the galactic habitable zone, the region within galaxies where it is possible for life to exist. Star formation in the outer regions of a galaxy is too low to create the necessary elements for rocky planets, while the inner regions, where stars are born and die quickly, are hazardous due to frequent supernovae irradiating the surrounding areas. This research suggests that the inner boundary of the galactic habitable zone may be farther from the galactic center than previously thought. So how would Betelgeuse's supernova appear from Earth? While the biosphere on Earth would likely remain intact, the spectacle would certainly be impossible to miss. According to astronomers Goldberg and Bauer, Betelgeuse's explosion would result in a luminosity roughly half that of the full moon, visible for several months. This brightness would be visible even during the daytime and cast shadows during the night. For several years after the explosion, the supernova's remnants would continue to be visible to the naked eye. Despite the fact that Betelgeuse's supernova would be a fascinating event, it would not come without consequences. The global fascination with such a phenomenon would be undeniable, but the long-term implications for Earth's environment remain uncertain. As scientists continue to monitor this red supergiant, we can only wait and see, in the hope that the threat, if any, is far off. The outcome of Betelgeuse's eventual supernova explosion would be a stunning sight, but not without serious repercussions. The enormous burst of light from such an event would likely be the second brightest object in our sky, right after the sun. During its peak, it would shine with such high intensity that it could easily rival the sun's light, even becoming visible during daylight hours and casting visible shadows in the darkest of nights. Despite its blinding light, it's important to note that visible light emitted by a supernova accounts for only a portion of the total energy produced. The more pressing concern is the high-energy radiation, typically released in the form of gamma rays, X-rays, and other types, which are extremely dangerous and have the potential to strip Earth's ozone layer, a protective shield that prevents harmful ultraviolet rays from reaching the surface. Without this layer, the Earth would be exposed to dangerous levels of radiation, increasing the risk of a mass extinction event. The aftermath of the explosion would not end with the immediate burst of energy. Cosmic rays, subatomic particles accelerated to nearly the speed of light, would follow, continuing to bombard the planet for hundreds of thousands of years. These particles have the power to penetrate Earth's atmosphere, further degrading the ozone layer and altering the. As our understanding of stellar evolution advances, scientists continue to closely observe Betelgeuse using space and ground-based telescopes. Sophisticated instruments monitor its surface activity, temperature fluctuations, and pulsation cycles in an effort to detect any early warning signs of a potential explosion. Interestingly, while Betelgeuse has returned to a more stable brightness since its dramatic dimming episode in 2019, it remains a subject of intense scrutiny. Astrophysicists have identified unusual convection patterns and persistent hot spots on its surface, anomalies that hint at internal changes deep within the star's core. Still, the timeline for a Betelgeuse supernova is wildly uncertain. It could explode within our lifetimes, or it may persist for another 100,000 years before reaching the end of its life cycle. The process of stellar death, especially in massive stars, is still not fully understood, and predicting the exact moment of collapse remains beyond our current scientific capabilities. Meanwhile, the interest in Betelgeuse has extended beyond academic circles. The public's fascination with the star has inspired books, documentaries, and viral internet theories, some sensational, others rooted in fact. Its looming potential for a dramatic end captures the imagination of people across cultures and continents, offering a rare reminder of humanity's fragile place in the vast, dynamic cosmos. Despite the uncertainty, one fact remains clear: when Betelgeuse finally goes supernova, it will offer a once-in-a-civilization event. Astronomers expect the light from the explosion to reach Earth within a matter of hours after the actual detonation, a result of the immense speed of light. Neutrino detectors across the globe may be the first to notice the event, as these elusive particles travel slightly faster than the electromagnetic wavefront and are less affected by cosmic dust. In the aftermath of the explosion, the debris field, rich in heavy elements like gold, iron, and uranium, will disperse across the cosmos, contributing to the cycle of star birth and planetary formation elsewhere in the galaxy. This is the paradox of destruction in the universe. Even the death of a star gives rise to new beginnings. Betelgeuse, once a vibrant beacon in Orion, will leave behind a legacy not just of light, but of cosmic transformation. The awareness of the potential dangers they pose has prompted astronomers to pay close attention to nearby stars, including Betelgeuse. Researchers have also uncovered another type of supernova that could pose an even greater risk. In some cases, a star's final explosion can be surrounded by a massive disk of gas and dust. When the shock wave from the explosion collides with this material, it generates an intense burst of X-ray radiation with the ability to travel vast distances. This emission of X-rays can deplete a planet's ozone layer, significantly raising the probability of a catastrophic extinction event. These types of supernovae, while not yet discovered close to Earth, could pose a serious danger in the event of one within a few hundred light years. The realization of this additional threat has caused astronomers to revise their understanding of the habitable zone within the galaxy. Previously, it was thought that the habitable zone extended nearer to the galactic center, but further evidence suggests the inner regions, where stars rise and fall quickly, may be far more hazardous than previously believed. The frequent supernovae in those areas could irradiate planets. Their close proximity renders them inhospitable for life. This has led scientists to propose that the outer boundaries of the galactic habitable zone may extend farther than originally thought. Looking ahead, what would a supernova like Betelgeuse's look like from Earth? While the actual explosion would likely have little to no impact on Earth's biosphere, the event would still be a spectacular sight. According to researchers Goldberg and Bauer, the supernova would shine with a brightness comparable to half of the moon's and be visible for several months. During its peak, it would be so intense that it could be seen during the daytime, casting long shadows even in the dead of night. As the supernova's remnants fade, they would remain visible to the naked eye for a number of years, making it an unforgettable celestial event. While the spectacle of Betelgeuse's explosion would enthrall audiences all over the world, its long-term effects on Earth remain a mystery. The radiation from the supernova would still pose a significant threat to the planet, especially with the potential for the ozone layer to be severely damaged. Although life on Earth may survive the event itself, the consequences of prolonged exposure to harmful radiation could alter the planet's ecosystems, potentially causing significant disruptions to the environment for thousands, or even millions, of years. In the long term, the possibility of a nearby supernova causing significant harm to Earth remains a matter of ongoing research and concern. While Betelgeuse's imminent explosion may not lead to the annihilation of Earth's biosphere, the emitted radiation would still present an incredibly powerful and dangerous force. The initial burst of energy from the supernova would likely include a combination of gamma rays and X-rays, which are capable of reducing the ozone layer, Earth's shield from the sun's harmful ultraviolet radiation. The absence of this protective layer would leave the planet vulnerable to dangerous radiation, which could have severe consequences for life, including potential extinction events. Following the supernova's explosion, cosmic rays, highly energetic particles traveling almost at the speed of light, would continue to pose threats. These rays have the capability to pass through the atmosphere and persist for hundreds of thousands of years. While the immediate blast from the supernova might be devastating, the long-lasting effects of these cosmic rays could prove even more damaging over time. They would continue to disrupt Earth's environment, preventing the recovery of its ecosystems and potentially causing prolonged periods of ecological instability. Iron-60, a radioactive isotope produced during supernovae, has been found in Earth's oceans and in lunar soil samples. This discovery indicates that Earth has previously been exposed to the remnants of a supernova explosion, possibly within the last few million years. Although astronomers currently do not see a supernova within a threatening distance from Earth, concerns arise when Iron-60 is found, highlighting the potential dangers posed by stellar explosions. These findings underscore the need to closely monitor the stars that reside within our galaxy, particularly those in the late stages of their life cycles, such as Betelgeuse. In addition to the threat posed by traditional supernovae, astronomers have also identified an additional potential danger, a specific type of supernova that occurs when a dying star is surrounded by a large disk of gas and dust. When the supernova explosion sends out a shock wave, this wave collides with the surrounding disk, producing a tremendous amount of X-ray radiation. This radiation can travel vast distances and has the potential to significantly deplete the ozone layer of any planet within a certain radius. A planet exposed to such radiation could face catastrophic consequences, including the triggering of an extinction event. Fortunately, no stars exhibiting this type of X-ray supernova are known to be located close to Earth. However, the discovery of this new supernova type has caused astronomers to rethink the boundaries of the area known as the galactic habitable zone, the region where it is most likely for life to exist. Previously, scientists assumed that the galactic habitable zone extended farther from the center of the galaxy. However, with the growing understanding of stellar behavior and the dangers posed by nearby supernovae, scientists are beginning to reconsider the stability and safety of regions once considered favorable for life. The inner galaxy, with its densely packed stars and frequent stellar deaths, might be more volatile than previously assumed. These areas could expose nearby planets to repeated and intense cosmic radiation, rendering them inhospitable despite their potentially Earth-like conditions. This realization has led researchers to propose that the most stable and life-sustaining regions might lie further out, in the quieter outskirts of the Milky Way. These outer zones, while less rich in heavy elements required for planet formation, may offer a safer haven from the violent deaths of stars. In these regions, the frequency of supernovae is lower, and the distances between stars are greater, reducing the chances of harmful radiation affecting planetary systems. As we expand our search for extraterrestrial life, this updated model of the galactic habitable zone plays a crucial role in guiding future missions. Telescopes and space probes may increasingly focus on these more distant, quieter regions of the galaxy. Meanwhile, the monitoring of stars like Betelgeuse continues, not only out of scientific curiosity but also as a necessary measure for planetary defense. The study of supernovae and their long-reaching effects also holds broader implications for understanding the history of life on Earth. Some scientists speculate that past mass extinction events may have been triggered, at least in part, by nearby supernovae. The discovery of isotopes like iron-60 in Earth's geological layers supports the idea that our planet has not always been shielded from such cosmic dangers. In the end, while the death of a star may seem like a distant and abstract event, its consequences can ripple across space and time, affecting life on worlds light-years away. The continued research into these phenomena not only deepens our understanding of the universe but also helps us prepare for potential cosmic threats in the future.